Okay, so imagine this. What if every single robot on the planet could learn from each other instantly? Well, that's not science fiction anymore. A team of ex-Google and Tesla engineers just dropped an open source OS designed to create a literal robot hive mind. And at the exact same time, China is betting trillions, yes, trillions, on dominating this very same space. The starting gun for a whole new kind of tech race has just been fired.
This quote right here, man, it just perfectly captures the two-sided coin we're all about to flip. I mean, are we building a globally connected intelligence that could solve humanity's biggest problems? Or are we building something that we just can't control? This isn't just about making better robots anymore. It's about what happens when they all start thinking together.
So, where does a hive mind even begin? Well, it all starts with a brain. Or maybe more accurately, a universal language that every single robot can speak. It's called OM1, and the big idea here is actually brilliantly simple. They want to become the android for robots. You see, right now, building a robot is kind of like the Wild West of early cell phones. Every company builds its own software from scratch, and nothing talks to each other. OM1 is totally open source and hardware agnostic. That means anyone can use it, and code written for one robot could, in theory, run on a completely different one. It's all about tearing down the walls between machines.
And you have to look at who's behind this thing. The company is called OpenMind, and it was started by engineers from the deep end of the pool at places like Google and Tesla. These aren't just a couple of coders in a garage. These are folks who have built massive, world-changing systems before. They get the scale of this challenge, and they're bringing that big tech DNA into the open source world.
But how does the whole hive mind part actually work? Well, it's through a protocol they call Fabric. Picture this. A robot in a lab in, say, Tokyo figures out a better, more stable way to carry a tray of glasses. Boom! It instantly shares that new skill to the Fabric network. From there, any other robot connected to the network, whether it's in a home in Ohio or a factory in Germany, can download and use that knowledge immediately. It's collective learning on a global, instantaneous scale. And this whole thing immediately sets up this huge philosophical battle for the future of robotics. It's the classic showdown, right? In one corner, you've got OpenMind's vision, an open, universal system, just like Android, powered by a global community of developers. And in the other corner, you have the giants, like Tesla, building everything in-house in a closed, tightly controlled ecosystem, kind of like Apple. The big question is, which approach is going to build smarter robots faster? Okay, so we have this powerful new brain. The very next question has to be, what kind of bodies are these brains going into? Because what we're seeing now is this software moving out of theory and into actual hardware that's designed not for a factory floor, but for your living room.
And you can already see this trend exploding. Just take these two recent examples. There's Engine AI's SAO2, which is a smaller companion bot, and then there's Fourier's GR3, a much bigger carebot that's focused on emotional support. Right away, you can see the market starting to split. One is a light, affordable friend, the other is a complex, sensitive caregiver. This isn't one-size-fits-all anymore. This is the very beginning of a specialized market for personal robots.
But let's just pause on this number for a second. $5,300. That's the price for the SAO2. We are not talking about the price of a car here, or even a hefty down payment. We're talking about a price tag that's in the same ballpark as a new high-end computer or a big TV. This is the moment, right now, that humanoid robots are stepping out of the science lab and getting a price tag for the living room.
But look, the real magic here isn't in the motors or the metal, it's in the AI. The SO2 uses a large language model to remember your conversations and actually adapt its personality to you. The GR3 takes it even further, using sensors to literally read human emotion and respond with its own. The goal here isn't to build a better vacuum cleaner, it's to build a companion. Now, while all these individual companies are racing ahead, there's a much, much bigger story playing out in the background. China is mobilizing a massive, national-level push to dominate this entire field, the field of what they call embodied intelligence, which is really just a fancy way of saying AI that has a physical body to interact with the world. And when I say massive, the numbers are almost hard to wrap your head around. Projections are suggesting the market for embodied intelligence in China could hit nearly 25 trillion yuan. That's over 3 trillion US dollars. For them, this isn't just another industry. This is the next economic revolution, on the same scale as electric vehicles. And this isn't just some corporate ambition, it is a full-blown national strategy. The plan is to coordinate everybody, the government, industry, finance, all of it, to solve the biggest problems in robotics. They're building a complete supply chain from the ground up and creating standardized training grounds where robots can learn in simulation and then immediately apply it to the real world. It creates this feedback loop for incredibly rapid learning.
So the end game here is crystal clear. China is done being a follower in global tech. With embodied intelligence, the stated goal is to become the world's leading ecosystem builder, the one who writes the rules and sets the standards for everybody else.
Which brings everything right back to that central conflict. We have these two immense forces, this open-source, decentralized movement on one side, and this top-down national strategy on the other. And both are pushing robotics forward, but into two very, very different kinds of futures.
So what happens next? Is the future of robotics going to be defined by these closed, tightly controlled ecosystems, whether they come from a single company or an entire national plan? Or will an open, collaborative, and maybe even messier community of global developers ultimately win out just by innovating faster? That, right there, is the real race, and the outcome is going to shape the world we all live in for decades to come.